Hi everyone, how are you feeling right now? Still eager to know more about brain? Since we are going into the topic of memory, let's start with the question first. Have you ever heard of HM? Yes? No? Stay tuned. In this topic, there will be three parts consists of HM, the different phases of memory, and the process of storing memories. Henry Molaison is a breakthrough to the understanding of learning and memory of brain. His case enables the surgeon to find out the function of medial temporal lobe is located at the temporal lobe. When he was an adult, the surgeon decided to remove his middle part of temporal lobe to cure his epilepsy. The surgery turned out to be a successful one, but just for a while. It is only then he is discovered to have severe amnesia after recovering from severe epilepsy. After the surgery, he can only remember recent events within few minutes. The researchers believe that the parts of brain removed has a vital role in transforming short-term memory to long-term memory. The parts removed are responsible for organization and permanent storage of memories. In conclusion, medial temporal lobe is closely connected to cerebral cortex and regions that are in charge for thinking and language. It is vital for forming, organizing, consolidating, and retrieving memory. Non-declarative memory: It is the ability to learn and remember everyday facts or events consciously. The areas that take part in this memory are cerebral cortex and hippocampus. Working memory can be simply understood as a middle person between short-term memory and long-term memory. It is located at prefrontal cortex and cerebral cortical area. Semantic memory stores facts and data. It revolves within the large cortical areas. When process different categories of information, the affected zones will expand. Episodic memory is a specific personal experience at specific time and place. This process takes place at the MPL, which manages the processing and storage of memories. Parahippocampal is assigned for the factual use of specific events, while hippocampus functions as a linkage between the two. Procedural memory is expressed in a skilled behavior and learned habits. It is processed by basal ganglia and cerebellum that responsible for motor tasks. Then amygdala will merge the memory of motor tasks with emotional aspects with the help of hypothalamus and sympathetic nervous system. This is to attach emotional significance. The storing of memories involves a persistent change in synapse. Thus, by turning on some genes may cause the stabilization of new memory due to the modification within neurons. For instance, a study is carried out by observing the sea slug memory at Tucson, California, where it can correlate the specific chemical and structural changes with simple form of memory in the animal. Long-term potentiation is a phenomenon of a long-lasting increase in strength of synaptic response from stimulation. It happens at several parts of the brain. It happens due to the changes in strength of synapses at contracts mainly involving NMDA receptors. The changes occur need to be stabilized through series of molecular reactions. The release of calcium ion into synapse, cyclic adenosine monophosphate, CAM molecule is activated in postsynaptic neuron. CAM molecule is then activated in some enzymes and also activates CRAB. Enzyme activation causes an increased number of synaptic receptors that makes it become more sensitive to neurotransmitter. Grab protein is a molecule that directs the synthesis of protein within the nucleus of the neuron. The product neutrophins helps in the growth of synapse and increase the neuron's responsiveness to stimulation. Most of the memory is stored in a distributed collections of cortical processing system. This shows that distinct parts of brain play critical role in pertaining memories. In conclusion, there is no single brain center to store memory.